Ever wondered how fast a car moves or how long it takes to travel from one city to another? What about the speed of a runner or train passing by? If you are ready to boost your problem solving skills, let's dive in. Time, speed, and distance are three fundamental concepts in motion. Like these concepts are used in our everyday life, such as traveling duration, calculating vehicle speed, and analyzing our running performance. So let's see the relationship among them. Our fundamental formula for this is speed is equal to distance by time. From this equation we can derive distance and time. Let's see for distance. Distance is equal to speed into time and time is equal to distance by speed. Let's understand these terms. Distance is the total length traveled by an object from one point to another. It's a scalar quantity, means it has magnitude and no direction. Let's say one example, a car traveling 200 km from one city to another city covers a distance of 200 km. Okay, let's see for speed. Speed is the rate at which an object moves. It's measured as a distance covered per unit of time. If train travels 100 km in 2 hours, then what's the speed means? We have to 100 divided by 2. We get 50 km per hour. Let's see for time. Time is the duration taken by object to cover a distance at given speed. Let's see one example. If a cyclist moves at 10 km per hour and needs to travel 50 km, the required time is 50 by 10. If we cancel out, we got 5 hours. Let's see units of measurements. To solve time, speed and distance problems correctly, we need to understand these units used for each. Firstly, speed. Speed is typically measured in kilometers per hour. We represent that as km by h, which is used in road speed vehicle speedometers. And we can measure this in meter per seconds. That can be represented as m by s. It is used in scientific measurement, physics problems, and even used in sports performance analytics. Okay, miles per hour can also be used, which is represented as mph. It is used in US, United States, and some other countries for road speeds. Let's see for distance. Distance is measured in meter, kilometers, miles. Meter can be represented by m. It's standard unit in physics and everyday's measurement. Kilometers. It is used for long distance such as road travel. Miles. Miles can be represented as mi. It is used in some countries like US and the UK for measuring long distances. Time. Time is the distance measured in seconds, minutes, hours. The fundamental unit of time is seconds. Used in physics, sports and short duration measurements. For minutes, we can represent it as min. It is commonly used in our daily activities and such as estimating time travel. Okay, let's see for hours. It is represented as h, used for long distance travel and scheduling. Many problems requires conversion difference between units and to maintain consistency. Let's see some problems for speed conversion. Since speed is measured as distance per unit time, we often need to convert between units. Kilometer per hour, km by h, to meters per second, m by s. We can convert this by multiplying 5 by 18. Let's say 1 kilometer per hour can be written as 5 by 18 meter per seconds. Let's see for one example, convert 90 km per hour to meter per seconds. 90 into 5 by 8, we got 25 meter per seconds. To convert meter per seconds to kilometer per hour, multiply by 18 by 5. Let's say 1 meter per second is equal to 18 by 5 kilometer per hour. Let's see one example. Convert 10 meter per seconds to kilometer per hour. 10 into 18 by 5 we get 36 kilometer per hour. Let's check for some distance conversion. 1 kilometer is equal to 1000 meter. 1 mile is equal to 1.609 kilometer. 1 yard is equal to 0.914 meter. Let's convert miles to kilometer. I am converting 3 miles to kilometer. 3 into 1.609 we got 4.827 kilometer. Let's check for time conversions. Hour is equal to 60 minutes. 1 minute is equal to 60 seconds. 1 hour is equal to 3600 seconds. Let's convert 2 hours 30 minutes into seconds. So 2 into 3600 plus 30 into 60. We got 2 into 3600 is equal to 7200 plus 30 into 60 we got 1800. So our final output is 9000 seconds. Let's jump into the sums using these topics. Finding a speed. A cyclist covers 90 km in 3 hours. Find his speed. So first identify the given values. So distance is equal to 90 km and time is equal to 3 hours. So our formula is speed is equal to distance by time. Let's substitute the values. S is equal to 90 by 3. If we perform the calculation, we got an output of 30. Let's jump into another sum. A car travels 240 km in 4 hours and 30 minutes. Find his speed in kilometer per hour. The given data was distance is equal to 240 km and time is 4 hours 30 seconds. First let's convert the time into hour. Since 30 minutes is 30 by 60 is equal to 0.5 hours. Then the total time already given as 4 hours. 4 plus which we got is 0.5. 4 plus 0.5 time is 4.5 hours. Let's use the speed formula. Speed is equal to distance by time. Let's substitute. We got 240 by 4.5 is equal to 53.33 km per hour. Let's jump into another sum. Our distance between the two stations is 540 km. A train takes 3 hours to cover this distance. Let's calculate the speed of train. Given data is the distance between two stations is 540 km and time is 3 hours. So let's substitute it in formula. Speed is equal to distance by time. If we substitute 540 by 3, we got, by cancelling out each other, we got 180 km per hour. So let's jump into the another average speed related problems. Firstly, we cover the basics of this. A car covers 60 km in 1 hour and 90 km in 1.5 hours. Find average speed. So the given data is total distance is 60 plus 90. We have to add those two values and then total time 1 and 1.5. We got 2.5 hours. So average speed is 150 divided by 2.5. As we know, speed is equal to distance by time. We got an output of 60 km per hour. It was a simple problem. Let's go to the another one. To and fro different speed. A person travels from A to B at 40 km per hour and comes back at 60 km per hour. Find the average speed. So average speed, there is a special formula for that. We can use this to simplify easier. So speed is equal to 2xy by x plus y. If we substitute it, we can get this. What is x and y then? X is the speed while going and y is the speed while returning, as it was a to and fro problem. So let's substitute the values here. X is 40 and y is 60. If we substitute in our average speed formula, we will get an output of 2 into 40 into 60 by 40 plus 60. If we multiply the numerator, we got 4800, and if we add the denominator, we got 100. So let's divide it. Zeros, if we cancel out all the zeros, we got 48 kilometers per hour. So let's discuss on this with different pattern, same time and different speed. A man travels certain distance at 30 km per hour and returns the same distance at 70 km per hour. What is the average speed of this? Well, it was a simple problem, so please solve this and comment your answers below. Let's jump into another sum. A man travels 60 km at 30 km per hour and another 90 km at 45 km per hour. Find the average speed. When distance are not same, we must use this formula for average speed. That is, speed is equal to total distance by total time. That's a speed formula. So let's given data was first part and second part. We can separate like that. Distance is equal to 60 and speed is equal to 30. If we calculate time for this, we got 2 hours, 60 by 30. Let's do the same thing for second part. Distance is 90 and speed is 45. If we cancel out, we got 2 hours. So our final output is total distance 60 plus 90 is equal to 150. Total time we have calculated previously, 2 plus 2 is equal to 4. Let's put it in speed formula. Speed is equal to distance by time. 150 by 4, we got 37.5 km per hour. Let's quickly jump into next topic, relative speed. Let's find the concept for this as a recap. Relative speed can be same direction, opposite direction. Same direction we have to subtract the speed. For opposite direction we have to add the speeds. So we have to know few more concepts for this. Kilometer per hour to meter per seconds we used to do multiply by 5 by 18. If it is meter per seconds to kilometer per hour means we have to multiply by 18 by 5. So quickly just do the sums. Two trains 120 meter 150 meter long are running in opposite direction on parallel tracks at 60 km per hour and 90 km per hour. How long will it take to cross each other completely? So it was like opposite direction, so we need to add those values. Total length we can add 120 plus 150, we got 270. Similarly, speed 60 plus 90, we got 150 km per hour. So let's convert the kilometer per hour into meter per seconds to put our final output. 1 km per hour is equal to 5 by 18 meter per seconds. Let's do this. 150 into 5 by 18, we got an output of 750 by 18. If we cancel it out each other, we got 41.67 meter per seconds. So if we put it in our formula, time is equal to distance by speed. Distance is 270 and relative speed which we have found previously, which was 41.67. If we cancel out, we got 6.48 seconds. So second sum, a man is running at 10 km per hour, a train 100 meter long running at 54 km per hour in same direction which overtakes him. Find time taken by the train to cross him. So it was same direction related sum. So we have to subtract the speeds. So let's do it. 54 minus 10. We got an output of 44 km per hour. So let's use the conversion same way as previous sum. 44 into 5 by 18, we got 220 by 18. If we cancel out each other, we got 12.22 meter per seconds. Distance covered we can calculate by length of the train, which is 100 meters. So that's a distance. So relative speed is, which we have done, 12.22 meters. So the time is 100 by speed 12.22. We got an output of 8.18 seconds. It was a quicker sum, right? So let's move faster to next sum. Two trains of length 100 meter, 80 meter are running towards each other. The first train run at 30 km per hour and second at 50 km per hour. In how much time will they cross each other? It was a simpler sum as the first sum which we have solved in relative speed. So solve this and comment your answers below. A simple tip for this sum is, we have to find the relative speed. As it was opposite direction, we have to add the speed, then we have to add length, and then finally we have to find the time using time formula. That's it. Let's see sums related to equations like that. A train passes a pole in 10 seconds and 200 meter long platform in 25 seconds. We have to find the speed. So when train passes a pole mean it covers equal to its own length, right? So let's the length of the train be L meters. So let's form an equation for this. Speed is equal to distance by time. Distance is L and time is 10. So this is the equation 1. When a train passes a platform, it covers a distance. So L plus 200 meters they have given as a platform length. So it takes 25 seconds to do this. So speed is equal to L plus 200 divided by 25. So this is the equation 2. Let's solve this equation to get an output of L. Equation 1 and 2 we are same. So we are cross multiplying this. 25 will go this side and 10 will come this side. So we got 25L is equal to 10 into L plus 200. If we go if we put this 10 inside this, we will get 10L plus 2000. If we further simplify this, 25L minus 10L is equal to 2000. 25 minus 10 is 15 is equal to 2000. If we put this 15 that side as denominator, L is equal to 2000 by 15. We got an output of 133.33 meters as an output. As we know the length of the train now, L is equal to 133.33 meters and it passes a pole in 10 seconds. Let's convert to km per hour. We know we have to multiply with 18 by 5. We got an output of 48 km per hour.